So you and your friends are in the science room, you're not mucking around or anything, asking really important questions, doing the work that's been asked of you, really pushing the boundaries of our understanding of humankind and the universe. Before you know it, well, it's time to do an experiment. Fantastic. So you have a look at the method, you prepare yourself, you read the safety instructions really carefully. And then you collect your data. Teacher comes back to you, and now it's time to put all of that data into a table. Problem is, how do we do a scientific table? Well, before we go into how do we do a scientific table, it's important to look at why do we do a scientific table. So in science, there can be lots of information, there can be lots of complicated ideas, and an important part of science is being able to communicate those ideas effectively. And it can be really easy to just throw lots of data and information at people, and they don't normally like that. All alone. So a better way is to use what's called a representation of the data or the information, whatever we're trying to communicate. And there's lots of different representations. Table is what we're talking about today. Others would be like a graph or a diagram, simple language, but it makes life a lot easier for people to understand what you're talking about. And whether or not you're pursuing a career in science, you will definitely be pursuing a career in being able to communicate to people, because it's a skill we do all the time. So let's have a look at some pointers for doing a good table. The first is we want to have headings for your columns and rows, depending if you need them for your rows. We're going to use what's called units in your headings if appropriate. A unit is just something like milliliters, grams, kilograms, etc. It's worth putting a bit of love into your table. You don't want to rush it. It's just worth putting 45 seconds just to rule your lines, because if it's very messy, people find it a bit hard to see what's going on. And it can also be helpful to know your independent and dependent variables. Alright, so let's have a look at an experiment and a pretty good table here. The experiment, quickly to summarize, is we're going to change the amount of water we're giving to a plant, and we're going to measure how much does that plant grow. So this table, I've got some nice clear headings here: amount of water given to plant and growth of plant. I've also got the units of measurement here as well, milliliters and centimeters. And then I've just listed the required numbers here. I can see 20 mils of water given to the plant means 4 centimeters of growth in a plant. Just a few other tips. This doesn't always happen, but a good policy is you can have your independent variable on the left-hand side, and you could have your dependent variable on the right-hand side. Another thing that we can see here is that it's ordered from lowest to highest for our independent variable if we're using numbers. So you don't want the 40 over here, then a 20 and a 10. It gets too confusing. Alright, this is a different type of table here. So instead of numbers, we're looking at what's called categorical changes for our independent variable. So there is no order to it. But I still have my headings here, so I might have changed the amount of water and light. So there's 2 independent variables there. But I can see normal water and light, good growth of plant. No water, no light, bad growth of plant. Units in the headings, don't need units in this heading. So this table is a little bit larger, it's a little bit more complicated, but we can still break it down with the same principles. We have our independent variable, so what we're changing on the left-hand side. So it's the different amounts of exercise: sitting, walking, jumping jacks, sprinting. And then we have our dependent variables on the right-hand side. So you can have, in an experiment, multiple dependent variables. You can also have multiple independent variables. gets pretty complicated if you do that, but it is possible. Again, I've got my headings, heartbeat, amount of sweat, general observations, and the units are there if required. So milliliters and beats per minute for these two. Don't need it for general observations or exercise. Lines are ruled. These are in order of perhaps difficulty. That's not necessarily required because it's not numbers, so we don't need to do that. Another thing that we can add to make this table even more professional is we can do what's called a figure heading or a table heading. So we could call it table 1, and we could put a little description of what this is. Perhaps it is the effect of exercise on the human body. You might also see in some scientific articles or some reports or even a test and stuff, maybe it's just called figure 1. Or it could be figure 2. It depends if it's the second image or the third image or something like that. It's all the same. It's just about what's called referencing. So you can talk about that specific table. You can say, as can be seen in table 1, sprinting has the highest heartbeat, whereas sitting does not. This is the professional upper limits of a table. What we have is multiple independent variables because we have salt concentration that's been changed, and then maybe we're doing the experiment several times. But all the same principles are the same. We've got our headings. We've got a table heading in here. You can put it at the top or the bottom. It doesn't really matter. Units are there where they are required. Numbers are listed in order of lowest to highest for the independent variable, and our rules aligned. Hopefully this helps. See you later.